Let's look at triangle similarity. There are only 3 triangle similarity postulates, and they look a little bit like the congruence postulates. The one difference, instead of sides being congruent, the sides will be in proportion. So first I said angle was not a triangle congruence postulate because it's a similarity postulate. Right, so angle, when 2 angles of one triangle are equal to 2 corresponding angles of the other triangle, the 2 triangles must be similar. Side, side, side. When 3 pairs of corresponding sides are in the same ratio, the 2 triangles must be similar. And we'll see some like that in this particular one. So for instance, if we look at the image for side, angle, side, so notice that 2 and 4 and 3 and 6. Right? So notice we could multiply by the same amount. So 6 is 1.5 times 4, and 3 is 1.5 times 2. So all the sides are larger by the same factor when we have side, side, side. And the last one is side, angle, side. So 2 sides of one triangle are in the same ratio as the corresponding 2 sides in another triangle, and the angles between the 2 sides are congruent. The triangles must be similar. Right? So you're going to look for that same pattern. Right? You got a pair of congruent angles. Are the sides in the same ratio? Are all the sides in the same ratio? Is one triangle bigger than the other by the same factor, or do you have 2 angles congruent? We'll also do a little bit of solving with similar triangles in this lesson. So which are pairs of corresponding sides? So we've worked on corresponding sides with congruent triangles. It works pretty much the same with similar triangles. Right? You're matching the ones that go together. All right? So if I go from 1 congruence marking to 2 congruence marking, I have side GP in the smaller triangle. If I go to the other triangle, all right, so I want to go from 1 to 2. All right, so O to W. So that means that, oh, not congruent, sorry. We've been working so much on incongruence. So GP corresponds, because they're not congruent, but they correspond. The OW is the same length as GP times the scale factor. So GP corresponds with OW. Right? Because we go from 1 to 2 congruence markings on the angles, right? So that means that, so maybe it would help if we write down the congruent angles. Angle G is congruent to angle O. So even though the sides aren't congruent, in similar triangles, the angles are congruent. Angle P is congruent to angle W, and angle C, actually we write the same direction. Angle I, so I'll include all the angles in pig. I is congruent to angle C, cow and pig. All right, so if we're going so G is congruent to O, and P is congruent to W, all right, that means that G to P has to correspond with O to W. All right? And then if we go from 2 to 3, that's PI. And PI would correspond with, right, so 2 to 3, WC. And then from 3 to 1, IG. That corresponds with 3 to 1, CO. All right, so just use your congruent angles to figure out which sides go together. What postulate can be used to prove triangle AEB similar, that's the mark for similar, to triangle ADC? Well, when you see when you see parallel lines, parallel sides, you think angles, right? Because when we have parallel lines, so if EB is parallel, oops, yeah, we'll call that F, to DF, then we know certain angles will be congruent. Specifically, in the triangle, notice that these angles are both above a parallel line and to the right of to the right of the transversal. That's what I was trying to say. So that means that angle AEB is congruent to angle ADF. We also have another transversal over here. So angle AB, angle ABE is congruent to angle AFD. And both of those are corresponding angles formed by parallel lines. And that's actually enough to prove our triangle's similar, but we may as well talk about the last pair of congruent angles. So if you notice, both of these triangles, and if you have trouble with these overlapping triangles, you can always draw it separately. So here's the smaller triangle, and then we have the bigger triangle. This is triangle AEB, and then there's the bigger triangle. Good enough. Triangle AD. Oh, apparently that missing letter was a C. I didn't look up there to see. Let's just fix where I see an F and make it a C. So ADC and ACD. There you go. All right, so if you notice, both of these triangles has an angle A. The two triangles overlap. So we know that angle A is congruent to angle A using the reflexive property. But we don't even need three angles, we just need two angles. And these triangles are similar using angle-angle similarity postulate. So if you see parallel lines, know that you have congruent angles, and you're going to be able to use angle-angle. Okay? Let's try the next one. And by the way, we have no side measures. So we couldn't use side angle side or side side side. We don't know the measures of the sides at all. So how could we determine if they were in proportion, in the same proportion? But we do know some congruent angles. Find x in the similar triangles. So similar triangles have congruent angles and sides that are in proportion. So these are both angle measures, and these two angles are congruent. So to solve this, we just need to set the angles equal to one another and solve for x. So we have 5x minus 2 equals 3x plus 46. Subtract 3x from both sides. So we have 2x minus 2 equals 46. Add 2 to both sides. 2x equals 48. And if we divide by 2, x is equal to 24. And we have solved it. All right? So if you've got, whether you have congruent triangles or similar triangles, they have angles that are congruent. So we can just solve this one by setting the angles equal to one another. All right? So this one wasn't too hard of a problem, right? You'll know what to do when you see this problem on the benchmark. What are the measures of the sides of triangle DEF if the perimeter is 30 centimeters? Well, on the last slide, I said the sides of similar triangles are in the same proportion to one another. That just means that I could take a corresponding side in triangle DEF and multiply it by the scale factor, and I'd get the corresponding side in triangle ABC. All right, so let's figure out the perimeter of triangle ABC. All right, so 15 plus 25 plus 20, all right, that's going to be, oops, why did I write 5? I was thinking 10 in my head and writing 5. All right, so that's going to be 60. All right, well, the perimeter of triangle DEF is 30. So 30 is half I think I wrote down the wrong. Well, 30 is half of 60. So we're just going to go with it. I had another number in my head that I was going to make my little triangle. But 30 is half of 60. All right, so let's figure out what the sides would have to be. So 30 is half of 60. So that means that each of the corresponding sides, so I didn't put the similarity statement here, but ABC is similar, triangle ABC is similar to triangle DEF. I forgot to write that in. So you knew how to match them up. So that means that AB corresponds with side DE. So AB is 20, DE is going to be 10. And if CB is 25, EF is going to be 12.5. And that means that, did I put that in the right spot? Yeah, but why do I have EE? D, E, F. This one's F, sorry. This was the last problem I wrote after writing a lot of problems. All right, so we've got AB goes with DE. All right, so AB is 10, AB is 20, DE is 10. BC is 25, EF is 12.5. There we go. And then our last side would be DF. All right, and DF or FD corresponds with CA. CA is 15. Half of 15 is going to be 7.5. And there we go. So let's add that up and see. So perimeter of triangle DEF, we have 7.5 plus 12.5 plus 10. All right, so 7.5, so 7 and 12 is 19, and 2 halves is 20. 20 plus 10 is 30. And there we go. All right, that works out. So you will see a problem like this, right? And it will give you the similarity statement. It won't forget. So all you have to do is find the perimeter of the triangle that you know all the sides to, right? Look at what the scale factor is, right? And if it's the smaller triangle that you're looking for, you're going to divide. How do we know this one was the smaller triangle? Well, 30 is smaller than 60, right? So it's the smaller triangle. So I'd have to multiply 30 by 2 equals 60. So that means that this triangle has sides that are twice as much as triangle DEF, and this triangle has sides that are half as much as triangle ABC. There we go. All right, so if you have questions, let me know. All right, and you can print this out if that would help you. I think that might be my last problem on this section. Oh no, I was going to do these ones too. All right, so I'm also going to do similar right triangles because, well, they're different. They're a little bit different standard, but they seem to kind of go together. All right, so we're just going to look at these. Actually, they're just one problem. All right, but it's how to match up the triangle. So the only thing you're going to be asked to do is be able to match up the corresponding parts. So it works out that if an altitude is drawn to the hypotenuse of a right triangle, it creates two other triangles that are similar to the original triangle and to each other. So all three triangles here, the big triangle, it's the whole thing, right? The medium triangle, actually let's just call this, I'll put an M for medium. And the small triangle, and then this one here, that's the large triangle. They're all similar to one another. So you just have to be able to match up the corresponding parts. Right? So I'm going to see if I can do it on the big one, and then I'm going to show you drawn out separately. I'm just hoping there's not too many colors visually. All right, so this is always the small side. I should call it small. The short side. All right, so we'll just call that the short leg. Since it's a right triangle, that's the short leg. On the small triangle, this is the short leg. On the medium triangle, and this is the short leg on the large triangle. Now we have a long leg. It's just not the hypotenuse. It's longer than the short leg. This is the long leg on the small triangle. This is the long leg on the medium triangle. And this is the long leg on the large triangle. And then, of course, the hypotenuse. The hypotenuse is opposite the right angle. This is the hypotenuse on the small triangle. This is the hypotenuse on the medium triangle. And this is the hypotenuse on the large triangle. All right, and feel free to use this to help you out. All right, so we'll learn how to. So you notice there's a lot of shared parts, and it makes for some solving, some easy solving using proportions that we can find all these missing parts of these triangles, and we'll learn how to do that next semester. I'm just going to ask, so here I have them all separated if that helps. I'm just going to ask you to be able to match up the corresponding parts at this time. All right, so here notice what's in the small triangle, medium triangle, and large triangle. Right? So here they are separated out. You can kind of, if that helps you out, they're turned a bit, so they're facing the same direction as the large triangle. So this small triangle here is turned around a bit, and here's the medium triangle. That one is turned around a bit to show you where the corresponding parts are. Right? Because they put the hypotenuse at the bottom. Here's the hypotenuse, so they made that the bottom on this triangle right there. Right? That's the hypotenuse. And here's the hypotenuse on the small triangle, right? So they've put that one on the bottom as well. And I guess I should have made it the same color as I have it marked up there. So if I make it the same color as the triangles up there, there's EF, right? So that triangle's turned around. This is the hypotenuse, because for all these triangles, the hypotenuse is on the bottom. They just turn the triangles around. And over here is the hypotenuse for the medium triangle. And that green there is the hypotenuse for the large triangle. I don't know if that helps, or if you like this diagram better, where I mark it all out. I kind of like this diagram better, only because this is how you'll see the problem, all right? And being able to match up which goes together. So short goes with short, long goes with long, hypotenuse goes with hypotenuse, right? So when you're naming them, right, you match up short with short, long with long, hypotenuse with hypotenuse, right? So I have it written here already, right? So if we look, and here it's written 3 different ways. So CB is the, I don't know which triangle, CBD is the medium triangle. They started with the medium triangle. Okay, so this is the, CB is the hypotenuse, AB is the hypotenuse, and AC is the hypotenuse. Right, so that's all, they're all the hypotenuse of the triangle. Right, so you match hypotenuse with hypotenuse. And then BD is the long leg, so you match long leg with long leg. Let's see, BC is the long leg on the large triangle, and CD is the large leg on the small triangle. So it was long leg. And then all of these would be short leg. So DC on the medium triangle, CA on the large triangle, DA on the small triangle. So that was the short leg. All right, so you're just matching up short with short, long with long, hypotenuse with hypotenuse. So here we just want to identify what are the congruent triangles. All right, and you'll have a question kind of like this. All right, LMN is the large triangle. So they've listed the large triangle first. MLO is the medium, and NMO is the small. Kind of helps to know who I'm looking at. All right, so LN right here, that's the hypotenuse. All right, let's see if they matched up the other hypotenuses. All right, so I use a different color. ML is the hypotenuse, right? And we know it's the hypotenuse because it's opposite the right angle. So that is the hypotenuse. That's good. And then NM. NM, that is the hypotenuse. All right, but it's not enough to have one side. Let's make sure the next side works out. All right, so NM. Right? NM is right here. It's the short side. Right? So this is the short side. It's right here. It's the short side on the large triangle. And then LO, oh, that doesn't work out because that's the long leg. So that doesn't work out. Long and short don't go together. All right, so that one is wrong. Let's try this again with B. And this is all you have to do. So it's like a little matching game. All right, so NM is the short leg. They started with short this time. And LO, that's the long leg. So no. If you have two that don't match, you can stop. All right, so LM is the hypotenuse, the long leg. Right, because the hypotenuse for the big triangle is opposite that right angle there. So that's the long leg. All right, LO, that's the long leg in the medium triangle. So that's long. MO, that's the long leg for the short triangle. So far, so good. Good so far. All right, oops, except I put short instead of long. It's the long leg. Am I looking at the right one? Yes, MO is the long leg. All right, we've already given up on B. MN. So MN is the short leg of the large triangle. And they're always in these same positions. That's what makes it a little bit easier to figure out. OM is the short leg on the medium triangle, and ON is the short leg. Let's make sure the last ones work. NL is the hypotenuse, ML is the hypotenuse, and NM is the hypotenuse. This is the one. Let's just make sure that the other one doesn't work. All right, so LM is hypotenuse. I won't draw on it because I already have it drawn, so we'll leave it the way it is. LM is hypotenuse. Wait, LM is long leg. I'm sorry, I'm looking at the wrong triangle. Oh, well, there it goes. This is the long leg on the large triangle, and this is the hypotenuse. So clearly wrong. If you see these matched up, these are talking about two different sides, so they're not going to match up together. All right, and that's the end of triangle similarity. Thanks for watching, and bye for now.